Hello you guys, welcome to another video session by Mr. Moyo. Today we're looking at triangles, okay? So we're going to try and go through all the basics as much as we can and as fast as we can so we can be able to get to the theories that are used in answering triangle questions. So one thing we know about triangles, by virtue of the name itself, okay, triangles, that tells you already that you're dealing with a polygon with because it's tri, it's going to be three angles. Okay, so it's a polygon with three angles, and by default, if you know about your polygons, the number of angles equals the number of sides as well. So this will tell you that it also has three sides, okay? And that's exactly what our triangles are. So I'm just going to draw a makeshift triangle. It may not have perfectly straight lines, but I'm sure you'll be able to work with that. So I'm going to call X, Y, Z. Notice how we use uppercase to denote uppercase or capital letters to denote angles, okay? And then we use lowercase or small letters to denote the sides, okay? Now notice how we come up with the sides concerning triangles. We look at the side opposite a particular angle. So what comes first is the angle, and then the side that's opposite the angle gets the letter that the angle is using. So we look, for example, at this side here. This side here, I'm going to be using a different pen, okay? So that side there is going to be opposite the angle x, so it becomes small letter x. This side here is opposite the angle y, so that becomes small letter y. And then this side here is opposite the letter z, so that becomes a small letter z, okay? So the way we denote sides is going to be via this method for all the other theories that we're going to be using. So notice how the side and the angle pair up. So sides and angles pair up, okay? So what comes first is the angle, and then the side is denoted by the letter opposite the given angle, okay? So again, we need to come up with what we call an included angle. So if I have two sides, okay, so I'll call this one side A and side B, then the angle that they form is called an included angle. This has got two implications on your theories. It's called an included angle. So if you have a triangle ABC, and you're told that you have sides A and B, then it means that they form the angle C, okay? If you have, which we can obviously see if we draw the triangle right quick. So that's A, B, C. So this is going to be side B. This is going to be side C, this is going to be side A. So notice how sides A and B make the angle C. Is that okay? So you can be able to make predictions using that. So if I gave you a different triangle, then I said I had a triangle L, M, N, and I gave you side M and side N, then it means that the angle that they make is going to be angle L, okay? So that's the included angle. Now, what does that got to do with anything? Considering how we deal with triangles, the first thing that we need to know whenever we deal with triangles, the first thing that we need to know, or we need to ask ourselves whenever we're dealing with triangles, is about the 90 degree, okay? So whether I have a 90 degree or I have no 90 degree in the triangle, automatically, when you know this, there's already a couple of things that you should be able to work with, and some things that you need to remove already. Because when you have a 90 degree, there's a couple of theories that work with that. So the next thing you need to ask yourself when you know that you already have a 90 degree is whether you have sides only or you have sides plus angles, okay? And this will talk about what then that takes you to. And again, we need to discuss concerning the area, okay? And same thing with this one, we'll also need to discuss concerning the area, right? And then concerning the no 90 degrees, again, there's two things that we'll need to ask ourselves. Whether we have this here, pairs of information, like we have there, okay? Whether we have pairs of information, or we have an included angle, which we've just covered right now. Included angle. Okay, so coming now to the theories themselves. So when you have sides only means that you're going to be using Pythagoras. So your c squared equals to a squared plus b squared, okay? And when you have sides and angles, it means that you're going to be using your SOHCAHTOA, okay? And then for the area, that's the only time that you can be able to use half base times height, because you have a base and you have a height and they have to be perpendicular to each other. That's where the 90 degree comes in. And then on the no 90 degrees, that's when we can be able to use, when you have pairs of information, then it's automatic that you can use the sine rule, okay? And this one will denote with, depending on whether we're trying to find the angle or we're trying to find the side, we're going to look at that further. And then for the included angle, we then use the cosine rule. And for the area, we use the theory half AB sine C, which if you take a look, already there is the idea that the C has to be the angle made by two sides, any two sides on the triangle, and the C has to be the angle that those two sides make. Hence, it's an included angle. Okay. Now coming right down to it. Now for the sine rule, the way you quote the sine rule depends with whether you want to find a side. So if you want to find a side, then you put the side on top. And notice how they pair up. Okay, notice how they pair up. That's why we say that we require pairs of information on this. Okay, similarly, if you want to find an angle, you put the angle on top. This kind of just saves, it's no difference, but it kind of saves you a stage or two from you trying to make something subject to formula. Okay, and then for the cosine rule, now to remember the cosine rule, we all know the Pythagoras formula very well, so we actually begin with that. So we know that we're supposed to have three sides in a triangle. So if I'm trying to find the third side, you can only find the side whose angle you're given, okay? We can only find side for whose angle we are given, okay? So that means that if I'm looking for angle A, so it means I have to quote my formula in terms of side A. So that means I'm going to have A squared is equals to B squared plus C squared. This is the initial part. That's where the Pythagoras part comes in, so you can be able to remember it. And then somehow you have to include the angle, remember? You have to include the angle, so the included angle itself, since that's the prerequisite for using the formula. And the way to do this is to include a part, which you will see as being, so it's 2 times this B goes there, this C goes there, B, C. And then we bring in, because it's the cosine rule, we bring in that angle with a cosine A. Why? Because this also has to give us that right there. So the next time that you're asked to quote the formula, if you're asked to find, for example, angle Z from triangle X, Y, Z, okay, then your quote is going to be Z squared, the side, equals to X squared plus Y squared, that's your Pythagoras part, minus, remember, it's 2 times the X and the Y, and then I need to bring in the cosine, since it's the cosine rule, of that side that I've been given, so it's cosine capital letter Z. Same thing, if you're given, asked to find angle M from triangle LMN, n. So that means that we're going to go small letter m squared equals to the other side, which are L squared plus n squared. That's the Pythagoras part, minus 2 with the L and the n. Okay, and then we need to bring in the cosine of the side that we're looking for, like that. So that's how we quote it. So if you're asked to find the angle, again, you're going to have to quote the side, the formula for the side, so that you don't have to claim too many formulas. There's way too many if you want to claim the ones for just the angles themselves. And I think it becomes a bit too bulky. And I think this is just about it. Considering the SOHCAHTOA, I think you guys already have a fair idea of how to use SOHCAHTOA. Sorry, SOHCAHTOA. So I'm just going to rewrite it here. There's so many methods to this again. Okay, just do the equals 2 divided by. That's what I call it. So equals 2 divided by, equals 2 divided by, equals 2 divided by. Okay. So I think that's it. That's it for triangles. You should be able to pretty much answer any triangles question, whether you're trying to find the area and you have a 90 degree, or you're trying to find the area but without a 90 degree. And whether you're trying to find a side or an angle when you're given a piece of information without a 90 degree, or you have an included angle without a 90 degree, or you have sides and angles, in which case you use a SOHCAHTOA with a 90 degree, and you only have sides, in which case you only use your Pythagoras. So these are like the prerequisites, and that's the first thing that you need to ask yourself: do I have a 90 degree or not? Because that points you as to what theories you can be able to use, or maybe not even be able to use. All right, ladies and gentlemen, thank you very much for joining me, and have a fantastic day. Hope to see you next time. Goodbye.